Alrighty, good morning and afternoon, seventh graders. Today we are doing multiplication and division equations, but with rational numbers. And our rational numbers are going to be like coefficients. So it's going to be like having, let me make sure we're on the right thing. It's going to be like having 2/3 x equal to, say, 5/6. Right? This is our rational coefficient. So that's what we're looking for. Okay, so we know that we have had one-step equations with adding and subtracting with rationals. Now this time we did last lesson our one-step with multiplication and division with integers. And the reason why we're doing this is because eventually here we are going to have two-step equations, and they are going to involve decimals and fractions as well. Okay, so that's where we want to make sure that we are on the same track with everything. If you are still keeping track, we are on our 5th lesson for this unit, chapter 6 in your textbook, if you need something to refer to. And we have 2 pages of notes today that's going to go after our previous notes. All right, so here we see 16 equals 2,500 times n. And it's going to be the same deal where we're going to need to notice that we have multiplication. And the inverse of multiplication is division. My pen is not wanting to identify. Okay, so we want to make sure that we are still dividing on both sides of the equal sign. Okay, you could mark it that you're multiplying by 1 divided by 2,500. You can put it this way so that we can identify that we are going to cancel out our quarter. Okay. So then all we're left to do is divide 16 by that quarter. But we have to remember a few things. Okay, we need to make sure that we remember how to divide with decimals. Right, and when we divide with decimals, remember we need to put the decimal to all the way to the right side to make it a whole number. Okay, so I'm going to do this in a different color to help identify that we are actually dividing. Remember, we always make our division. I put my, nope, that's not work. What is going on with our smartboard today? Let's write my number first. And then what's on top of the fraction bar goes inside. So this is where things get different. Because remember, we need to take this decimal and move it over to the right. Is not quite sure what's going on. We are lagging behind on things here today. There we go. We want to make it a whole number. So instead of dividing by a quarter, we're dividing by 25. And the same thing here. Here's technically where my decimal was to begin with. And I need to move it 2 places over. Then if you remember, we do the same amount of places, and then we bring our decimal up to the top. Okay, so right here is where my decimal is going to go. All right, so I know 25 can't go into 116, but it can go into 166 times. We subtract our 150. with 10 left over. So remember this little zero? It's coming down. So we have 100. We'll think of it as a dollar. How many quarters make a dollar? 4. So our solution of what we're trying to say we're doing here is that n equals 64. But then, as always, we have to come through and check our work. Remember to check the work. You rewrite the equation. So 16 equals 2500. And instead of n, I put my solution of 64. Right? If I had 64 quarters, we want to know, is that going to make $16? Which it does. Right? We need to pause that. Make sure you get copied down into your notes. If you didn't print your notes, you're putting this into your math notebook. Next, we have one that looks like division. All right. So I want to get P isolated. So my job, instead of dividing, is now going to be multiplying. Remember, because this one's written as a fraction, we're going to write it as a fraction. It helps us then identify this has 100 too, that we can cross cancel those out because 75 cents over 75 cents makes a whole. Then all I'm left with is my P is equal to, well, how do we multiply again? Let's do a quick review. We got a lot of extra stuff going on here today. All right, we have to line up our decimal. We don't have to line up our decimals. That's only when we add or subtract. Okay, we multiply numbers as usual. So I'm going to rewrite this. I'm going to do my work in a different color. Okay, so I'm taking 12, a negative 12, times my 75. Okay, and because they're different signs, I already know my product is going to be a negative number. 5 times 2 makes 10. 5 times 1 plus 1 is 6. So remember, you need to put another 0 before you multiply your next number. 7 times 2 is 14. With another 1. And then an 8. Then we add these up. All right, now is my answer going to be 900? Well, what's our last step tell us we need to do? It does not matter who is bigger. So it doesn't really matter which number we put on top. I could have put my 75 cents on top and my 12 on bottom. It's all about the opposite. Okay, so that's how we know if we get a negative or positive. All right, so I need to count how many place values do I need to go here? 1, 2, 1, 2. So we're going to say my answer is negative 9. Because if you think of it, 75 cents is like 3/4 of a dollar. So 3/4 of a negative 12 is going to be negative 9. Right? And then as always, we need to check our work. Okay? If I have negative $9.75, is that going to make a negative 12? It does. And we are good. And the reason why I know that is I have done the math already off to the side that, well, not off on the side of here, but off on my own paper. Now, if you need to, if you know you're not good with your decimal and your fraction multiplication, go ahead and try doing it on your own on paper. If you're still not sure, bust out your calculator and check your work. As long as you're showing your steps, that is the most important part here today. All right, let's go to our next page. Fraction coefficients. Okay, so we have some word problem to help us understand this a little bit more. So 2/3 of Chen's homeroom class plan to participate in the school talent show. If 16 students from the class plan to participate, how many students are in the homeroom class? Right, so we have a bar diagram to help represent. Right, so this whole bar diagram represents what is the number of students in the class. We know 2/3 of these students, though, are planning to participate in the talent show, okay? And we are saying that there are 16 of those 2/3 of the class that are participating. So that kind of shows the model, right? So, but our job is to find out the whole bar. What is it? So we need to write the equation from the bar diagram. Okay, so 2/3 of something is actually going to equal our 16. Okay, so this is our equation. 2/3 of something equals 16. So now our job is to actually solve. Now, remember, our whole job is to get x by itself. Okay, we see multiplication, but we're dividing with a fraction. So if you remember how we divide by fractions, we multiply by the reciprocal. And the reciprocal is taking your fraction and flipping it over. Now remember, whatever you do to one side, you have to do it together. Remember what number is under every whole number? A 1. The reasoning why we do that is to get x by itself, and you can get x by itself if you are multiplying by 1. My 3's cancel and my 2's cross cancel. So then I'm left with only an x because they have all canceled each other out. Okay. Now 16 over 1 times 2/3. My 3 and my 1 cannot cancel. Now I can take 16 and multiply it by 3, or I can go ahead and cross cancel my 16 and my 2. 2 goes into 2 one time. 2 goes into 16 8 times. So instead of having to take 48 and divide it by 2, I can easily take my 8 times my 3, which gives me 24. So we are saying that our x equals 24. Remember, you have to show, are you multiplying or dividing? And you need to show what are you doing to both sides of the equal sign, then your solution. Once you have your solution, go back and check your work, okay? We make mistakes, even I make mistakes, so that's why we need to check our work. It is very important. Remember, when you check your work, you are rewriting our equation, but you are replacing the variable with your solution. Okay? And then whenever you have fractions, give your whole numbers a 1 underneath. That's 24 wholes out of 1. Okay? Well, I notice I have a 3 and a 24, and 3 goes into 24. 3 goes into 3 one time, goes into 24 8 times. Then I'm just left with 2 times my 8, which is 6. This time we had no negatives to worry about, so that helps out. So that means this whole part right here represents 24 kids. And if I took 24 and split it into thirds, I have 8 kids in each of these sections. and only 2/3 of the kids actually participating into the talent show. That's what that model actually represents. All right. So now we have another one, but this one has a negative in it. All right, so 3/4 of x equals a -9. Okay, so if we have that, we need to know that we have 3/4 of something. So we took something, split it into fours, and we only want to know what 3 of them are. Okay, but we know that represents an actual -9. But we don't know what all of this is. This is our x. Okay. Some reminders when we're multiplying with fractions. Remember, we multiply by the reciprocal. Okay. And we always use cross products to reduce if possible. Okay. On your right side, rewrite the equation. 3/4 of x equals a -9. And then we're going to go through and do our steps. Yes, we really want to divide by a 3/4, but that's not how we can solve it. Remember, you have to do multiplying by the reciprocal if we have a fraction coefficient. Okay, so that is why I'm going to multiply, but instead of by 3/4, I'm going to multiply by 4/3. I'm going to give my -9 a whole number underneath, and I'm putting 4/3 on both sides. The reasoning, my 3/3 cancels and my 4/4 cancel. They all make 1 by cross canceling. So then x equals, well, let's look. Is there anything I can cancel? I can't cancel a 1 and a 4. Okay? You have a 1 across from it, diagonal from it, you can't get rid of it. Okay, but can 3, my smaller number, go into 9? It can. 3 goes in 3 one time, and 3 goes into this, and keep our negative with it. So then all I'm really left with is a -3 times 4. Remember, opposite signs makes a negative number, and 12 times 4, or 3 times 4 is 12. And as always, we want to check our work. Rewrite your equation. Replace x with your solution of -12. And we want to know, is that going to equal a -9? Well, if I put my 1 under here, I'm now going to look. Can I cross cancel before I actually multiply? Well, can 4 go into 12? Yes, it can. Oh, it did select me a different color. There we go. We can cancel 4. 4 goes into 4 one time, and then this a -3. So then I'm really left with a -3 times a +3. Is that going to equal a -9? Remember, if you're using an integer man, if you have a positive and a negative, our answer is a negative. So I do get a -9. Okay, these might take a little bit more work than what we did yesterday with the integers, but that's perfectly fine. All right. So now we have a -2/3 x equals a -6/15. Okay, so rewriting it over off to the side, I have my -2/3 of x equal to negative. My job is to get that variable by itself. whether it is X, P, T, whether it is on the left or right side of the equal sign, I want to get it by itself. Okay? I need to now multiply by the reciprocal. Okay? Remember, the reciprocal is taking a fraction and flipping it. So instead of 2/3, it's a negative 3/2 going on both sides. Whole reasoning is because when you cross cancel, they turn into 1. And remember, if you have a negative, it makes a positive, so I still have my positive x. So let's look, can we cross cancel so I'm not having to do a bunch of division later? Okay, I like to look and make sure if there's any cross canceling. Okay, normally I would say diagonally as a smaller number, so can 2 go into 6? Well, 6 is even, so yes. Okay, so we have now a -3 and a 15. 3 goes into 15 5 times, and this stays as a -1. So I'm really left with this -3 times a -1. And remember, 2 negatives will make a positive, because this tells me to do the opposite of this one. So I get x equals a 3. That's my solution. We need to check our work. Okay. So when I check my work, rewrite it. 2/3 of x equals a -6/15. Oh, you know what? I forgot to replace my x with my solution. That. Easy peasy. Okay. Instead of x, I'm putting 3. I can put 3/1. Oh, you know what? You did not touch my air. Or I didn't touch my air. I forgot I had a 5 down here. So it's 3/5. There we go. That's why we check our work. Because I would have seen, oh, well, I would have gotten 2, and 2 is not the same as my 6/15. Okay? Make sure then as well that we remember we have numbers down here to be multiplying. They don't always cancel the 1. All right. So if I take a -2 times a +3, I get a -6, and 3 times 5 is 15. Now, are these reduced? No. If my 6/15 would have been a reduced fraction, like it should have been, I would have cross-canceled my 3's and got a -2/5. So when you're checking your work, you might not always want to cross-cancel. So if you notice what you're trying to equal is not a reduced fraction, then don't cross-cancel. Okay? So one thing we always need to remember, it's something we keep telling you about. Whatever you do to one side of that equal sign, you have to do the same thing to the other side. So if you notice all of my problems, I put them where I multiplied by the same reciprocal. If I had a negative with it, a negative was on the other side as well. If you need to, pause this, fill in your notes, and then we're going to start the homework. All right, one-step equations with rational coefficients worksheet. To solve an equation when the coefficient is a fraction, remember what we need to do. What is it that we need to do? We need to multiply each side of the equation by the, I'm horrible at spelling. I always have to look back and see how it's spelled. All right, IPR. By the reciprocal. Remember, that means you're taking your fraction and flipping it over. All right, let's see. What's a difficult one here for us? Let's do number 4 and number 6. All right, let's start with those. All right, so this time our fraction is actually on, our variable is on the right side. Now, I can still multiply both by the reciprocal. Okay, remember reciprocal is flipping your fraction, so it's really 3/5. And whenever I do to one side, I gotta do the other side. What that does is cause my 5's to cancel, because 5 over 5 makes 1, and 3 over 3 makes the other. Because if I was to multiply, I would have had 15 over 15. Well, there's 15 slices of pizza, and your brother ate 15 slices. He ate the whole pizza. All right, so I'm only left with my n on the right side. Now when I go to cross cancel or go to the other side on the left side, I need to either multiply it out and divide, or I see that there is some cross canceling I can do. My cross canceling this time goes with my 15 and my 5. 5 can go into 15 3 times, and 5 goes into 5 1 time. So we're just left with 9 as our solution. Now, that's only part of the work that you should be showing, because on each of these, you need to be showing that you are checking your work. Remember, you check your work, rewrite the equation, replace x with your solution. All right, I can see I can cross cancel here. 3 goes into 3 1 time, and 9 3 times, and 5 times 3 makes 15. Bada bing, we are good. Pause this if you need to. All right, number 6, mixed numbers. Remember, we can't just multiply mixed numbers. We have to turn them into those improper fractions. We call it, some of us call it the Concord C. So I'm actually going to rewrite this as an improper fraction. 6 times 4 is 24, plus 1 is 25. Equals a negative 3 times 3 is 9, plus 1 is 10. Now I can go ahead and show my work of multiplying by the reciprocal. Okay, I'm going to multiply the reciprocal. That means I'm going to flip the 6/25. Whatever I do on one side, I have to do to the other side. Now here I might be able to do some cross canceling to make life easy. Right? Make life easy for yourself. And if you need to, get out a multiplication chart if you're not good at finding out what can be cross canceled. That's an awesome tool to use. All right, I see 3 and 6 can both be cross canceled because they can both be divided by 3. What about 10 and 25? 10 can't go into 25, but they do have the greatest common factor of 5. If I divide both by 5, this is really a 2. And this one is a 1. Okay, so then we get a different sign. So C equals a negative 2 times 2 is 4. Okay. But then we need to check our work, as always. Lovely checking work. Okay. And when I'm going to check my work, I'm going to leave it as an improper fraction. So I'm going to use what I rewrote. See if we do get our negative 3 1/3. All right. Can I cross cancel anything? My 5 can go to 25. And maybe 5 and 1. 6 and 4 can be divided by 2 to get a 3 and a 2. All right, doing the cross canceling can look messy as long as you stay with it and you know what you're doing. You need to even rewrite it that it's really 5/3 times 2 over 1. Okay. Oh, I forgot my negatives. All right. Oh, well, it's negative, not this. Positive, negative. Different signs gives me a negative answer. And 10/3, is that equal to negative 10/3? Yes. Okay. So there's 2 problems out of your homework. All right, the other side is decimals. I'm going to start one with you, but I'm not going to finish and do all of the work with you. Okay? Just want to remind you of how you're going to be dividing. Remember, it doesn't matter what side our variable is on. If it is on the right side, that's what we're trying to get rid of. Okay? I'm dividing both sides by my negative 4,500. Whatever I do to one side, I got to do to the other side. If you need to, do your division off to the side. Okay? How many times can this go? But before you can do anything, you have to turn that 4,500 into a whole number, which means this one's getting moved over and our decimal goes right above there. Okay? So I'm going to leave that one at. You're going to need to finish that one up. I wanted to help set it up for you. All right. I hope you guys have a great day. If you get stuck, send a message to your teacher.